biotechnology in plant production, and I did the title a little bit broader. I said plant breeding, teaching and research at BOKU. Why is that? First I start with some general, what is the philosophy of what we do? Plant breeding is the science, the art, and the economic activity with the aim to change or to improve the genetic constitution of crop plants according to our needs. So we want to improve plants at the genetic level. The teaching commitment of our group is moderate, I would say. We are teaching in bachelor studies at BOKU. Basically, this is a basic course in plant breeding. We have some courses in the master studies, especially in the fields of agrobiology and applied plant sciences and horticulture. Oops. So I thought I have kicked out petroculture and some master studies. Plant breeding is a very multidisciplinary field of research, where genetics is an important part, but it also has a touch with agronomy, phytopathology, botany, and so on and so on. So it's a multidisciplinary field, so it fits well into a life science university. We have 5 groups currently working in plant breeding. 3 of them are at IFA, and 2 of them are at BOKU still, but which should move to the UFT. So in short, we will have more groups working in plant breeding here at this campus. Now I want to give you a short insight in a few aspects, which will be discussed later in more details. One is by disease resistance and plant pathogen interaction, and this work is guided by Professor Mark Clemens, and he has a special interest in fungal toxins in plant pathogen interaction, also in biocontrol, and all you know, this is a big field, a cooperation field with IFA, one of the classical IFA cooperation success stories. Mark Clemens does a lot of work in artificial inoculation methods, developing testing systems for wheat, barley, and maize for fusarium diseases. Mark is also guiding a big project on bioactive compounds, a technopole project where 3 institutes of IFA are cooperating closely in the identification and characterization of antifungal bioactive compounds, which should have a potential in biocontrol of diseases. In my own group, I focused mainly on molecular mapping and molecular breeding methods in cereals, mainly wheat and barley, with a focus again on fusarium diseases. This is a long tradition in our group, but in addition to other diseases like rust and bunk diseases. One example I want to show is molecular breeding. We were successful in the past to identify QTL, so-called quantitative trait loci, linked to fusarium resistance genes, one for instance on chromosome 3b, another one on chromosome 5a, and then we used markers, molecular markers linked to those genes in a molecular breeding approach and could convert susceptible plants into more resistant plants. And this is again an important field of research here at IFA, because we do not only want to move those genes using markers, we also want to identify the genes behind them, want to identify the function. And that is the next project. We are involved in a big special research project funded by the FWF, coordinated by Gerhard Adam, where our part is to look into the genomics of fusarium resistance using different toolboxes. It will be explained later. Mainly, we try to look to use a transcriptomic and gene validation work in this project. And this is a really international, national, a BOKU consortium with some international links, for instance, to the United States and to Germany. As I said, there is 2 other groups working in plant breeding at BOKU who will come to this campus soon. One is the group by Heinrich Gausgruber, who does mainly wheat breeding, barley breeding, and who is very good in biometrical methods useful for plant breeding. And I have another group in Vienna, Johann Vollmann, who is doing on the one hand a lot of projects in soybean, which is a protein crop in our environment, but also of course an oil crop worldwide. And most importantly, as a link to our institute, is that Johann Vollmann, together with Martin Pachner, is working on oil pumpkin research. And also we will hear about the oil pumpkin very soon, an example of a project that is done managed by Johann Vollmann and Martin Pachner. And one outcome of the pumpkin research, for instance, in the past was again an FWS project where for the first time the series of really useful DNA markers, in this case microsatellite markers for pumpkins, have been developed, so that we have now about 500 microsatellite markers for pumpkin maize which can be used. Ongoing work is to use to do high throughput sequencing in pumpkin to identify more markers like SNP markers in this crop as well. So this is a short overview of the portfolio.